Okay, so welcome to our second day's worth of data tracking. Today we are going to look at SID 2 and 3, where we are going to describe data sets using shape, center, and spread, looking at questions number 2, 17, 27, and 32 from the 2018 NC Math 1 released items. So diving right into question number 2, it says a set of 9 data points is shown below. Here we go. Which statement is true if a 10th data point of 45 is added to the data set? A, the mean and median will both increase. B, the mean will increase and the median will decrease. The mean will increase and the median will remain the same. Or the mean and median both will decrease. Well, since we're talking about mean and median, of course I'll have my Desmos open, the NC test version. I'm simply going to click plus to create a table of my values. Notice I'm only going to put my values in X1. So I'm going to go ahead and do that. 8, 11, 12, 10, 9, 7, 5, 3, and 9. All right, so here are my data sets. I know that Desmos will do mean and median for me. All I have to do is click the next empty box, functions, stats, and I'm going to choose mean just because it arrives or is there first. So looking at the fact that all my data is in X1, instead of having to retype all of my data, I'm just going to type in X subset 1, because remember, that's the list that all of my things are in, X1, okay? I don't have to close parentheses, but I'm a little anal about that, so there we go. And we see here that our mean is 8.22, okay? For median, I'm going to do the same thing. I'm going to click my little keyboard if it's not still open, function, stats, and then I'm going to choose median. Again, all my data is in X1, so I'm just going to type in X subset 1. Okay, and I see that my median is 9. So personally, I would go ahead and write down my information. That way I have something to reference. So I'm going to go ahead and write down, so mean, or X bar, equals 8.22, and my median, MED, is equal to 9, okay? And I'm going to just go back to my table, my original table, and I'm going to enter in that 10th data point that they asked me about, of 45. So here is 45, and let's see what changes. I don't have to recalculate anything. It'll do it all for me. So mean, using the data that I've now entered, including the 10th point, the mean is now 11.9. The median now is 9. So what is true based on the answer choice given to us? Well, I know that the mean increased from 8.2 to 11.9. So is A true? The mean and median both will increase. Well, did the median increase? No, so can't be our answer. The mean will increase, but the median will decrease. Well, yeah, the mean increased from 8.2 to 11.9, but did the median decrease? No, I've got 9 and 9, so that can't be my answer either. Moving on, the mean will increase and the median will remain the same. Well, did the mean increase? Yes, 8.22 to 11.9. And did the median stay the same? Well, yeah, median of 9 with my original data and median of 9 with the 10th point. So C is going to be our answer. Okay, so looking at number 17, the question reads, the choices below are data sets. In the choices, W is a constant. Each choice has the same mean. Which choice has the greatest standard deviation? Okay, so the first way that we're going to look at this problem is by really like dissecting what the question is asking for. So even though I've got these expressions here like W minus 2, W minus 1, the thing that we really need to focus on first is that W is a constant. Well, we know that if it's a constant and if the mean is the same for each one, then W has to be the same value for each one. So the simplest thing we can do is just assign W a value of 0. So let's go ahead and do that. So we're going to say W equals 0. Okay, so now thinking in those terms, I want to go ahead and kind of add or subtract each of these terms. So I've got w minus 2. So if w is 0, 0 minus 2 is going to be -2, 0 minus 1 is -1, so on and so forth. So what I'm going to actually put into my list in Desmos is just the constant term that I see in each of these expressions, okay? So remember, if you're not sure what to do, you're going to click the plus and table. So for answer choice A, I'm going to go ahead and enter what I see. So we have -2, -1. Remember, w is 0. 0 plus 1 is 1. And 0 plus 2 is 2. So that's what I'm going to enter in. -2, -1, 0, 1, and 2. Okay, then what we're going to do in the box following it is go ahead and calculate the standard deviation. We can do that by clicking on the keyboard, Functions, Stats, and then STDEV, which is standard deviation. Okay, now because for this answer choice, it's in list X1 or X subset 1, I'm going to type in X1, and it'll calculate the standard deviation for that particular list. There it is, 1.58. Okay, so we're going to do the same thing, enter the data for choice B, C, and D. I'm going to do B in X2, C in X3, and D in X4, okay? So I'm going to go ahead and pause the video for just a second and enter that data so you don't have to watch me do it, and I'll be back with you in just a moment. Okay, so I'm back. I've entered in all of my data. Again, you all saw me enter in x of 1 and standard deviation for x of 1. Now I have x of 2 with the standard deviation. Here's it, 2. I have x of 3, and then that's my standard deviation for that. And x of 4 with the standard deviation of 2.12. Okay, remember, this is x of 1, x of 2, x of 3, x of 4. Now we're just going to compare. Okay, and we're looking for which one has the largest standard deviation, of course, because we have the word greatest. So which one of these standard deviation numbers is largest? Well, I'm going to just go by process of elimination, starting from the top down. So x of 1, which remember corresponded to A, well, it has a standard deviation of 1.58. Okay, now just skimming through what we have in Desmos, I know that that's going to be the smallest one. So is that our answer? No, because the question asks for the greatest standard deviation. Okay, so then I'm going to move on. So looking at answer choice B, here it is, an x of 2. That's going to be 2. Well, let's compare 2 to 2.23 to 2.12. Well, is that larger than the others? No, it's not, so it can't be an answer either. Looking at C, or x of 3 here, I've got 2.23. Okay, and looking at D, I've got 2.12. Well, which is going to be largest? Well, I know that 2.236 is larger than 2.121. So our answer choice would be C. Okay, so the next question that we're looking at is number 27. This is the table below shows the weights of 8 different bears at a zoo. If the weight of the polar bear is removed, which statement is true? Well, first I'm going to look for the polar bear. Here it is, right there. So I'm just going to highlight it so I know this is the one I'm looking at. And I want to figure out which of these statements is true. A, the mean decreases more than the median because a polar bear is a high outlier. The mean decreases less than the median because the polar bear is a high outlier. The mean decreases more than the median because the high value balances the low value. Or D, the mean decreases less than the median because the high value balances the low value. So if every single answer choice asks about the mean and median, guess what? I need to create a table by going to plus table and then entering in all the values that I see. Because I only have weight in pounds, I'm just going to enter in information in x of 1. Okay, it all talks about mean and median, so I'm going to go ahead and calculate that. Remember, I'm going to click on my next empty space. I'm going to show the keypad, click function. Normally trig will be highlighted, but you need to go to stats, then mean, okay? And because all of our information is x of 1, we're just going to type in x of 1, okay? Now it's calculated for us. We're going to go ahead and do the same thing for median. So functions, stats, median, okay, x of 1, and then we're going to see what it is. Remember, I like to go ahead and write my information down so it's easy to go ahead and compare. So we have mean, so x bar is going to be, that's very dark, you can't see that. So x bar is equal to 369.8. 0.375, okay? And median of original data is 290, okay? Now I want to know what happens when we remove or take out the polar bear. And remember, we went ahead and highlighted the polar bear, so the polar bear was 1,000, so let's just go ahead and delete that data point and see what happens, okay? So remember, it'll go ahead and calculate it as long as I've put in a place for mean and median. So the mean now is 279.286, if we round it, and the median is 280. So let's compare those two sets of data, original and augmented. So the mean decreases more than the median because the polar bear is a high outlier. Well, did the mean decrease? First of all, let's check if that's true. Did the mean decrease? So original 369, augmented 279. Did it decrease? Yes, it did decrease. Did the median, did it decrease more than the median? Well, the median was 290 and in the original data, and it was 280 in the augmented data. So how many points did that actually change? Well, that changed 10 points. Okay, so the mean did decrease more than the median. And is it because the polar bear is a high outlier? Well, looking at the data, is 1,000 a high outlier? Yes, it is. So that could be a possible choice. So I'm just gonna put a little mark next to it personally. So the mean decreases less than the median because the polar bear is a high outlier. Well, did the mean decrease less than the median? Well, no, the median only decreased by 10 points. So that can't be an answer. So I'm just gonna mark it out altogether, okay? The mean decreases more than the median because the high value balances the low value. Well, does 1,000 balance 225? Well, no, we know in mathematical terms, we're not really talking about balancing values. So we can't use that as a sound argument, okay? The last one we're gonna look at is the mean decreases less than the median because a high value balances the low value. Again, we know that the mean didn't decrease less. In fact, it goes, the mean decreased by, I don't know, something like 90, whereas the median decreased by only 10, so that doesn't even make sense. And then again, we're not using sound mathematical arguments because we're not talking about values balancing. So the only choice that works for us is A. Okay, so the last question we're going to talk about for SID 2 and 3 is question number 32 from the active, and it says place, click, and drag the data sets below into the appropriate rows in the table. So of course, if this was the interactive version of the test, you'd be dragging things where they belong, but since I have a paper pencil copy, I'm going to show you how we could solve that in Desmos as well. Now this one might be a little bit new for you, so please feel free to pause the video and take really detailed notes on how to create the table that I'm about to show you. So unfortunately, the test version of Desmos will not create box and whisker plots, but we can do something that still shows us the spread of data. And all we're gonna do is this. So I'm gonna click plus, I'm gonna click my table, okay? And I'm gonna enter in the values that I see as x1, x2, and x3, okay? So first we're gonna do x of 1. So we have 15, 25, 35, oops, should probably move boxes, 35, 45, 55, and 115. Okay. All right, I finally got it right there. Okay, so that's the first thing that we're going to do, but we're going to plot those as if they were coordinate points. Now, because I only have one value, we're going to make the assumption that they are x values, okay? So we're going to plug in 0 for all of the y values here, and that's going to give us a coordinate point, okay? We're going to let Desmos plot that for us. So I'm going to move the table so we can see those, or move the graph so we can see those. Okay, so here are our points. Nice and neat, right? Okay, so we have everything through 115. Okay, I just wanted you to see that. Now, what I'm going to do is I'm going to use what we know about mean, because all of these are asking us relative to the mean, how is the spread of the data, okay? So here I'm going to go ahead and calculate the mean. So functions, stats, mean, okay? Now, because I'm just dealing with this one, which we've designated as x1, I'm gonna type in x of 1. That's all the data I've got in right now, okay? And I see that value of 48.33, okay? So I let Desmos do all the work for me, but now I'm going to use the mean as a coordinate point as well, okay? So here's my coordinate point, 48.33. And following the pattern that we've already established here with the x value being whatever number they give us and the y value being 0 to create a coordinate point, we're going to do the same thing. So 48.33, comma 0, okay? And we're going to ask Desmos to label that for us, okay? All right, so now it should be labeled some different color, whatever that different color is, okay? I'm going to zoom out just a little bit, or zoom in, excuse me, so that it's a little bit clearer on how everything is spread. All right, so here is what we've got. So we have all of our data points, and of course we can click on them to see what they are. And then we have our last data point here. Okay. So what we're gonna do is look to see how close the data is compared to the mean, okay? So in this particular example, which way is the outlier going? Is it going to the left or going to the right of the data? So remember, left, right. So in this case, the graph would be skewed to the right because I have a long tail. Imagine this was a box and whisker plot, a long tail going to the right. So I would have dragged this set to skewed right, okay? So because I can't, I'm just gonna put an R next to it, okay? We're gonna do the same thing for the other set of data and just see what we come up with. So I'm going to erase all the data and reset it, okay? So we have x of 15, 75, 85, 95, 105, and 115, okay? Remember, I'm going to fill in 0 for all of my y values because I'm trying to create coordinate points here. And notice it's filling in my points on that side. And here. All right. So because I've changed my data, the mean has changed, which means I need to change my data point for median, or excuse me, for mean. So it's 81.66. So I'm going to change this to 81.66, okay? And I want to see how the data is spread compared to that. Okay, well, here is my mean, okay? Here is the majority of my data, okay? And here is my outlier. On which side is my outlier? The left or the right? Well, it's on the left. So I'm going to say that data is skewed to the left. So I'm just going to write a big L over it, okay? Well, by process of elimination, that would mean that our data 15, 25, 35, 45, 55, and 65 would be symmetric about the mean. But just to prove it, we're going to go ahead and put that data in. So 15, 25, 35, 45, 55, and 65. Okay. Now remember, it's calculated a new mean for us, so we need to change our labeled point. So the new mean is 40, so let's go ahead and change the coordinate point to 40, comma 0. Okay, and here it is. So now we see our mean here, and we see our data, 3 on the left, 3 on the right of the mean. So that would definitely be symmetric about the mean. So I'm just going to put an S over that. So you would have been able to drag all of those pieces to their correct location. Okay, and that wraps up a review of SID 2 and 3 for today. Please check with me about your next assignment.